Hello everyone, welcome back to my channel Science Sutra. If you have not yet subscribed my channel, please do subscribe Science Sutra. Okay, in this video, we are learning a new concept called refraction. Okay, it's an optical phenomenon of light. Okay, this phenomenon you will see in the chapter called light, refraction and reflection. Reflection you already learned. Okay, in this video we will be learning refraction. See why we will see refraction. Okay, to see this is a glass containing water. Okay, inside this glass I put a lemon. Okay, if you see from outside, what you can see, the size of the lemon to be bigger in size, right? The size of the lemon is bigger. Okay, I will remove that lemon and you can see the difference, right? You can see the difference. The lemon size, if whatever the lemon that I kept inside the water, I have removed that lemon, and if I take that outside, you can see the size of the lemon to be small, correct? I will put the lemon again inside this water. What you can see? You can see the size of the lemon to be bigger, right? This is one example. Okay, one more example I will show you. If you see this, the pencil which I kept inside the water, it is seen like it is bent in nature, right? Do you see the bentness or bending of a pencil which I kept inside the water? Of course, you can see that. When I kept the pencil, okay, in a glass containing water, you will see the bending of the pencil. Okay, this is also one live example. Okay, and if I remove this pencil, it is observed to be straight, correct? The same pencil, when I kept that inside water, what you will see? You will see the bending of the pencil. You can see the bending nature of the pencil. Okay, why do you see that? All that I will explain in this video. Okay, one more example. What is that example means? This you had to do at home. Okay, you cannot experience or you cannot see this experiment here. What is this means? I kept a coin. Okay, I kept a coin inside an empty beaker. Okay, I'm holding this beaker like this, but I'm not seeing the coin yet. I'm not seeing the coin. Okay, it is somewhere here. What I will do, in order to see the coin, I'm pouring some water in this cup. Okay, if I pour the water inside the cup, okay, what happens? The coin, whatever I kept inside the beaker, now I can see the coin. Now I can see the coin somewhere here. Okay, okay, why it is like that? I will explain to you. Right now, we need to discuss why we are seeing this kind of optical phenomenon. Why the light will show this kind of phenomenon. Okay, that we need to know. See, before knowing that, what we need to write? We need to write some properties of light that we know before only. What is that? As we all know, how the light will travel? Light always travels correct? Light always travels in a straight line. Okay, when light is traveling, when light is traveling in a medium, right? See, when light is traveling in air, how can you see the light rays to be? Light rays to be moving in this straight line. The light always travels in a straight line. Okay, that is one property that we know, right? Then we know the speed of light, right? The speed of light in vacuum. In vacuum. What do you mean by that? Vacuum. Where there is no air, nothing. You will see nothing there. Only an empty space you will see. Okay. The speed of light in that case, it will be equal to 3 into 10 power 8 meter per second. Okay. Then the speed of light, in air, it is approximately equal to 2.999 something 10 power 8. So we are approximately taking the value as 3 only. 3 into 10 power 8 meter per second. Okay. And we know the speed of light in water. What will be the speed of light? We need to know. It may be around 2.5 10 power 8 meter per second. Okay. And speed of light, why I am writing all these values, you will get to know shortly. Okay. Speed of light in glass. What will be the speed of light? It is around 2 10 power 8 meter per second. See, if you observe the values cleanly, okay, if you observe carefully, what you will conclude? The speed of light is different in different medium. Correct? That is one point. What is the other point? When light is traveling in a medium, when light is traveling in air, its value is around 3, right? When light is traveling in water, its value is around 2.5. When light is traveling in glass, its value is around 2. That means when light is traveling from a medium to medium, its value is decreasing. Correct? See, if I am talking about air, the value of speed of light will be 3. Correct? The speed of light in water, it is around 2.5. When the speed of light in glass, it is 2. Why it is so? Have you ever thought that? Why it is like that? See, air, as we know, air is said to be gaseous in form, right? It's a gas. Then how the molecules will be? The space between the molecules will be more, right? The space between the molecules will be more. As a result, the light can travel fastly without any clubbing or without any clashing with the molecules. Correct? So the speed of light will be 3 only in air. If I am talking about water, what is that water? Will be in liquid form, right? So the molecules in liquid also you will see relatively closer, correct? But not tightly packed, correct? So the light maybe go in this way, okay? So the speed of light in water is 2.5. But if we come to the glass is solid, right? Here you will see the molecules to be closely packed. So what happens when light made to pass through this glass, the speed of light automatically decreases to 2. So only we are seeing the speed of light values to be decreasing in different mediums. Okay. Next, what point we need to write means as speed of light is decreasing, or else you can take changing. As speed of light is changing, what happens? The direction of light ray will also be changing. The direction of light ray is also changing, or else you can write there you will see the bending of light ray. As speed of light is decreasing or changing, what happens? Automatically the direction of the light ray is also changing, or you will see the bending of light ray. Okay, the bending of light ray. Okay. So, now how we can define the refraction by knowing all these things? We can define easily. How we can define? The bending of light, the bending of light ray, or else you can write change in the direction of light ray, change in the direction of light ray. Okay. The bending of light ray or change in the direction of light ray when you will see when the light is traveling, when light is traveling from one medium to another. Correct? One medium to another. In that case, we will call the phenomenon as refraction. See, if the light ray is moving from air to water, what you will see inside the water? You will see the bending of light ray, right? As a result, you will see the bending of the pencil, which I showed before, right? If you observe this keenly, you will see the light ray is traveling from air, whatever the empty or whatever the space that is present outside this glass is called air. This is the whatever the water surface present at the top is called the boundary. Okay, and this light ray is entering from air to water. As a result, what we are seeing? The bending of light ray. Okay, as a result, we are seeing the bending of light ray. I will explain that. Okay, why it is like that. Okay, so this is the definition. If you want, I will put a box for that. You can refer this definition. This is a very easy definition which you can remember. Okay, correct. The bending of light ray or change in the direction of the light ray when light is traveling from one medium to the another. Okay, and this how we can write diagrammatically. If I take an incident ray like this, it is falling in this direction. Okay, and this is the boundary. Okay, and this will be the normal. Correct? And what you will expect? What you will expect? This is, I will take this as air medium and this as water medium. Okay, what you will expect? You will expect the light ray to pass in this direction. Correct? As you know, the light ray will pass or will move in a straight path. But actually the path of light, it will be in this direction. Okay. Why it is like that? It is because of change in the speed of light. When the light is traveling in air, the speed of the light will be more. As and when it reaches the water surface, what happens? Automatically the speed of light value will be decreased. As a result, you will see the bending of light or change in the direction of the light. And this phenomenon, what do you call? This phenomenon as refraction. Correct? Then can you see the refraction when the light ray is entering in this direction normally? Can you see that? No, you cannot see that refraction phenomenon. Then what kind of incident ray you had to take? You had to take the incident ray to be in oblique direction. Okay, obliquely. Phenomenon is called to be the refraction. So this is how we can define the refraction. How we can define the refraction? Refraction is nothing but the light ray traveling from one medium to another by changing its path or by bending the light ray when it is traveling from one medium to the another, and that phenomenon is called to be the refraction. Correct? Now we need to understand what is a rarer medium and what is denser medium. We need to understand. What is that? Rarer medium. The medium where the speed of light increases. Okay. Denser means the medium where the speed of light decreases. Okay. This is one point we need to understand about refraction. There is one more point. What is that means? See, when light ray travels from rarer to denser medium, when it is traveling from rarer to denser medium, the light ray after refraction, it will bend towards the normal. That is the important point you have to mark down. What is that? When light ray travels from rarer to denser, how the ray will bend? You can see two cases, right? Either the ray can bend like this or like this. But how it is bending? It is bending towards the normal. So how you can conclude that? When light ray travels from rarer to denser medium, it always bends towards the normal. That is the case that you will see here. Okay. Next point, when light ray travels from denser to when light ray travels from denser to rarer medium, what happens? It always bends away from the normal. So this is the case. Okay, then how you can write diagrammatically? You can write how means I will show you. Okay. First, we need to take a boundary. Then what I need to take? I need to take the light ray to be in oblique direction. Okay. Oblique direction means it has to make some angle with the boundary. Okay. Now I need to draw a normal. Then what I need to take? I need to take this as a rarer medium, this as a denser medium. What happens when the light ray is traveling from rarer to denser? It will always bend towards the normal. Okay. This angle and this angle we have to take. And one more point you have to consider here. When the light ray is traveling from rarer to denser medium, it will make some angle, right? Here, the I value is always greater than R. What is that R here? R is the angle of refraction. The angle of incidence is always greater than the angle of refraction when the light ray is traveling from rarer to denser medium. Okay, this is first case. What about the second case? I need to consider this incident ray, but here I need to consider this as denser and this as a rarer. So, after refraction, what it will do? It will bend away from the normal. And if you see this, what you can write? The angle of incidence is always less than angle of refraction. Okay. And this is the case where you will see the denser and the rarer. Okay. I hope you have understood about the definition of denser, rarer and the definition of the refraction. Correct. Now we need to write the reasons why we will see the size of the lemon to be bigger, and why we will see the bending nature of the pencil when it is kept inside the water, that we all need to know now, one by one. Okay, that I will explain now. First case, I will take the cup where I will keep a coin. Okay, this is the cup which I have not filled with water initially. Okay, and I kept a coin. When I am seeing, I am observing here. My eye is here. I am observing here. What happens? As you all know, because of a reflection, what we can see? We all seeing the objects, right? As you all know, how we are all seeing the objects. So when a light is fallen on this object, whatever the light that is reflected back, that will enter our eye. As a result, you are seeing the object. Correct. The same thing you will observe here also. You can ask me, when a light is showing a refraction, can we see a reflection phenomenon also? Yes, you can see the reflection phenomenon also. Or how we can write that means, so when light is falling here on a surface, small amount of light will get reflected back in this direction also, and then it will show the refraction as usual. Okay, small amount of light will be reflected even in refraction phenomenon also. Okay, that if we see a coin, okay, my eye is here and I am seeing the coin by holding like this. Correct. I am holding the cup like this and I am seeing. But now I can't see the coin. What I will do? I will do by pouring the water. I am pouring water and now I can see a little amount of the coin. Okay. By pouring water, what I can see? I can see the presence of coin inside this cup. I am not seeing like this. I am seeing obliquely. I am seeing obliquely by keeping the cup in this direction. If I keep this cup in this direction, I can see the coin, okay, a little bit. When I can see the coin? By pouring the water inside this coin. See what happens by pouring the water inside this coin. Initially, I have not put any water in this cup, right? So, whatever the light that is falling on this coin, it is making the light rays to reflect it back. It makes the light ray to reflect back. But why we are not seeing that coin? Because of the cup which is present, okay, it is making the reflected ray, okay, or it is absorbing the reflected ray. Okay, so we are not seeing the coin. As soon as we fill the cup with water, I'm filling the cup with water. What happens? The light ray which is traveling in air now, it will come in contact with what? It will come in contact with water, right? When the light ray that is traveling in air, it is coming in contact with water. Or else you can take, when the coin is kept inside the water, okay, the light ray is traveling from denser to rarer. Rarer means here air. This is air and this is water, correct? Whatever the light ray, I am concentrating only on the coin. Okay. See, I am here. Okay, I am seeing this coin. I can see the coin now. Why? Because whatever the light ray that is falling on this coin, it is traveling now from water to air. That means we have to see the bending of light. Bending of light ray we can see. We can see the bending of light ray. Whatever the light ray that is bending, it is making me to see the coin. Okay, whatever the light ray that is bending, it is entering my eye, so only I can see the coin. But the actual position of the coin is here. Okay, but we can see the coin somewhere here. Why? because the bending, whatever the light ray that is bent, I'm making that to converge at a point, but I'm seeing the coin to be here. It is an illusion. It is all because of refraction. Okay, it is all because of refraction. We are seeing the coin here. Okay, this is how we can explain this concept of cup filled with water and with a coin. Okay, next I need to take a glass filled with what? Water. Glass filled with water, and what I'm doing, I'm placing the pencil inside this. Okay, here whatever the pencil which I kept inside this, it is showing the bent in nature, but you cannot, but actually it is not bent because of the phenomenon of refraction. You are seeing that here the light ray, what it is doing, here the light ray, it is traveling from water, from water it's traveling. As a result, we will see the bending nature of light. Okay, if I make this light ray to converge at a point, we will see the pencil to be here. That means we are seeing the bending nature of the pencil. Okay, this is all because of refraction. Okay, then how means you had to explain this. If I take the glass filled with water, I'm placing the pencil. Okay, what it will do, the pencil, whatever the light rays that is falling on the pencil, since it is moving from water to air, it shows the bending nature of the light ray. And if I converge all these bent rays at a point, the pencil is appeared to be here, but is not actually here. It is appearing to be here. As a result, we can explain the refraction by taking some examples. Okay, all this you can explain to your friends, those who don't know about this refraction. Okay, I hope you like this video. If you like this video, please like, share and subscribe to my channel. Okay, and please do comment if you like this video. Okay, thank you.